Good morning. Hope my slides are visible.
Yes, ma'am.
Okay. So today let us discuss uh, under supervised learning network, the first neural network model, that is Perceptron neural network model. So today I'll be discussing only Perceptron neural network model, that is the basic or the simplest one under supervised learning. Okay. So a few basic things with respect to this learning technique I had already discussed in my previous class. Uh, so this is the basic block diagram of a supervised learning network. So you know the output results. Okay, you need to make use of that target output. You have to compare it with the output which you have got. Then based on the difference, we will change the change the weights and we do the training. So this is the basic perceptron neural network model. If you can just recall, so this is the input, this is the associator unit, this one is the response unit, and here we are going to calculate the error if any. So because it's that will be a comparator, like say output unit minus desired output will give you the error. So this sensory units, they are connected to associator units, okay, with fixed weights, normally 1 0 minus 1, okay, which are assigned at random. uh, So normally we go for here binary activation function with the threshold value. This response unit will have a threshold value theta. Uh, Normally say 0 or 0.2, 0.5. It will be, we need to decide it. So here the output signals which are sent from the associator units to the response units are binary. So later I'll be discussing, maybe in next class I'll be discussing Adeline neural network model. So the difference between the Perceptron neural network model and Adeline is Perceptron takes binary response and computes an error used to update the weights. So here it is in terms of binary response. Okay, just keep in your mind, it is the response unit. So it is binary response. Okay. Uh, yeah, this is the perceptron neural networking model. Like any other model, it calculates or it computes the sum of weighted combinations of its inputs. Okay, so something like this. The diagram with the bias value, activation threshold unit, and the output unit. So this is the flow chart. If I simply explain the flow chart, I think I had just revised it in my last class. You will not understand. Rather, I will tell you, I'll take up one or two problems today and I'll tell you how to calculate how to train the perceptron neural network model. Then only it will be clear. Okay, if required, I'll come back to this flow chart later. Yeah, let me just tell you a few things about perceptron learning. So here we are we are updating the weights. Okay, so Wi is equal to, so the first diagram, one second. Yeah, so Wi is equal to, here the meaning of this is the Wi old is equal to Wi new is equal to Wi old plus delta Wi. So what is the delta Wi? Delta, that variation in the weight, it depends on the alpha. So alpha is called, it is called learning rate. Okay, alpha is called learning rate, say 0.1, 0.2, 0.51. Okay, and T is the target value. Please note, T is the target value. Alpha is the learning rate. O is the whatever the output you have got, the obtained output. Okay, and Xi is the input which you are going to give at that point of time. Okay. So if the output of the perceptron model is equal to the uh, target value, this is O, okay, it is not 0. If the target value is equal to the perceptron output, then weights are not changed. We don't change any weights. If it is not same, then we change the weights. How do we change the weights? Based on this particular formula. Along with the weights, we also change the bias value, whatever the weight corresponding to a bias, that is 1, that also need to be changed. So finally, how does the perceptron model converge? So it converged, okay, based on the condition that if the training data is linearly separable. We have seen this linearly separable concept in one of the classes. So when you plot a line, so it should be able to separate the input positive response. It should be able to separate the positive response with the negative response. So that is called linearly separable. Okay, or else you have to do some 2 to 3 or 3 to 4, or maybe you have to increase the epochs, and you have to see that the weights will become constant. Okay, this is the condition. So what is epoch? Presentation of the entire training set to the neural network. So when you present one complete set of the inputs, then we say that one epoch is over. Okay. Second time, when you repeat it for the second time for the same inputs, then it will be second epoch. Sometimes if you are writing a program for the neural network training, you can repeat this. You can increase the number of epochs and see whether it converges or not. Okay. Of course, error all of us know. Now, what is target value? So target value is the value which is desired. Okay. So target value is the desired output. So desired output, when I say, I have given here example for a NAND gate. If you write say 0 0 0 1 1 0 1 1 AND gate, if we write with this binary input values, so all of us know that the output is 0 0 0 1. So this is the desired output. We have to get this output only. So what is the O then? O is the output which the network has given. So what is our ultimate aim? We have to train the network until O becomes T, okay, with minimum permissible error. Then I is with respect to, we call it is with respect to input, W is weight, and LR is the learning rate. Some textbooks you will see alpha, some textbooks use eta, okay. So let us use this alpha as the learning rate. So how does a training algorithm do? It adjusts the neural networks weights to map inputs to output. Okay. Use a set of sample patterns where the desired output is known. The purpose is to learn to recognize features which are common to good and bad exemplars. Okay, that let us take one example and do it. Okay, I'll go to one example. One simple example I'll take. Okay, all of you can take down this example. Implement and function, implement and function using Perceptron neural network for implement and function using Perceptron neural network for bipolar inputs and targets assume W1 is equal to W2 is equal to B is equal to 0 initially. Theta is 0, that is the threshold value. Then alpha is the learning rate 1. Okay. So this is the question. You have to implement AND function using Perceptron model with the bipolar inputs and targets. You need to assume W1, W2 and B. It's given assumption. You have to assume start with 0 initially. And the threshold values also it is given. It may be given theta is equal to 0 or 0.2 or 0.51. Anything can be given. So the learning rate also here it is specified alpha is equal to 1. You can take alpha is equal to 0.1, 0.2, 0.3 if it is not given. Okay. So here let me just write the truth table. So x1, x2 and this is the target. Since it is bipolar inputs, so let me write 1, 1, 1 minus 1, minus 1, 1, minus 1, minus 1. So here we know this is 1. For all this it is minus 1. If it is binary inputs and targets, you would have written 1 1 1 0 0 1 0 0 1 0 0 0. Okay. So how will our neural network model be? So it will be this is this is our inputs x1 and x2, and this is our output y. This is x1, this is x2. So this is the bias value. W1, W2, B. This is the neural network model. This then finally, so now your aim is to calculate W1, W2 and B. Okay. So let me just do this problem. So first step is we need to calculate the y in. We need to calculate y in using our the expression which we normally use b plus x1 w1 plus x2 out w2 for the first input. X1 is equal to 1, x2 is equal to 1. This is the first step. Okay, so we have started with the b value. You can see here b value 0, w1, w2 both are 0. So here what happens, the y in will be 0 plus x1 into 0 plus x2. 1 x1 is 1, x1 is 1. x1 1 into 0 plus 1 into 0. So y in is 0. So what is the input to the output neuron? That output layer y input is 0, right? So now we know that here it is given threshold value also 0. Theta is also 0. This is given, right? This is given. So we'll just write the expressions for y in. So y is equal to f of y in, which is equal to 1 0 minus 1 if y in is greater than 0. So it is actually y in greater than theta. Second condition, if y in equal to theta. So here it is 0. It is minus 1 if y in less than theta. Okay, so less than 0. So these are the conditions now for the output. Okay, theta value is already mentioned in the problem. So if y in is equal to greater than 0, it is 1. If it is equal to 0, it is 0. If it is less than 0, it is minus 1. Okay. Now with theta is equal to 0, y in is 0. Okay, so y is equal to 0 here. Now with this y in is, I just color it. So y in is 0. So what happens now? Our y value, this condition is satisfied. You can see this condition is satisfied. So we can write that with the theta is equal to, I just write it, with theta threshold value is equal to 0. My y in calculated is 0. So hence I have got the output y is equal to 0, right? So now comes the important part. Check whether target value is equal to y. This is the, in the flow chart, if you see, this is what comes here. I'll just show you. Okay, so here we have calculated. See, this is the part which you have got. We have calculated the net y in, then we have used applied activation, obtained y is equal to f of y in, that we have calculated. Now we are checking whether the value, whatever the output we have got, is equal to the target value. Okay, now, so here just go back, see what is the target value. Target value is 1. Okay, so here I'll write it. Now target value t is 1 and y is 0, right? T is 1 and y is 0. T is 1 and y is 0. Just 1 second. Okay, so t is equal to 1, y is equal to 0, right? This is the condition we have got. So t is not equal to y. So what is the conclusion? T is not equal to y, right? So now what you need to do is you have to update the weights. You have to update the weights. Okay. Now, so we know that W1 new is equal to W1 old plus alpha Tx1. So calculate W1 new, which is equal to W1 old is 0 plus alpha is 1. It is given. Target value is 1 and x1 is 1. So this is equal to 1. W1 new is 1. Similarly, W2 new you can calculate, which is equal to W2 old plus alpha into T into x2. x2 is 1. This is also 1. Then B new you can calculate, which is equal to B new is, it is B old plus it is alpha into T. So 1 into 1, which is equal to 1. So please note that we have got the new W1, W2 and beta. Okay. So here one set of inputs you have calculated and we have got this. So I'll just color this because I'll develop one table later. Okay, so I can enter these values when I develop a table. So with the input x1 and x2, 1 and 1, we have got these weights. Okay, now what we'll do is we will repeat this for second inputs. Okay, so now second inputs. Second inputs are, it is x1 is equal to 1, x2 is equal to minus 1. Okay, x1 is equal to 1, x2 is equal to minus 1. So what is the first step? First step is you calculate y in. Y in is equal to, again, you know the expression, it is beta, b plus x1 w1 plus x2 w2. So b plus B plus x1 w1 plus x2 w2. So B is whatever the previous value, 1 plus x1 is 1, w1 is 1 plus x2 is minus 1 plus w into w2. W2 is whatever this. So now here you have got 1. Y in is 1. So from the activation function, which you know, so if it is 1, if y in is greater than 0, so we know that the output y is equal to, if y in is greater than 0, it is equal to 1, right? So now here I can write y is equal to f of y in, which is equal to 1, right? This is important. So let me go to yeah, now next part is you check whether t is equal to y, check whether t is equal to y. So t is what here? Minus 1. Y what you have got is 1. So t is equal to minus 1, y is equal to 1. Now t is not equal to y, right? So t is not equal to y. You need to update the weights. Again calculate w1 new. W1 new is equal to W1 old, that is 1 plus learning rate into target value into X1. X1 is 1. So this is equal to now 0. Next, W2 new, this is equal to, again W1 old is 1 plus 1 into minus 1 target into minus 1. So it is 2. B new is equal to B old plus alpha into minus 1 is equal to 0. Please note 0, T, 0. This is the weight you have got for the inputs. Your inputs are now 1 and minus 1. Okay, second row in the truth table. For 1 and minus 1, you have got the new weights 0 to 0. Okay, only second input is done. Now what you have to do, you have to go for the third inputs. Okay, so this is second inputs over. Now give third inputs. So what are the third inputs? Third inputs are x1 is minus 1, x2 is 1. Okay. So now you calculate y is equal to, y in is equal to, yeah, b plus x1 w1 plus x2 w2. b is 0 plus x1 w1 0 plus x2 is 1, w2 is 2. So this is 2. So what is y? Y is equal to f of y in. So if it is greater than threshold, then the output is 1. So here threshold is 0, our y in is 2, so the output is 1. This is important part. So you have got y is equal to f of y in, which is equal to 1. Now what is the target value? Target value is minus 1. What is y we have got? Y we have got is 1. Y is 1. So T is not equal to Y. Now update the weights. Update the weights. So again, W1 new, W2 new, B. These things you can calculate. W1 new is equal to W1 old. W1 old is 0 plus alpha into target into x1. This is 1. W2 new is 2, just check. Yeah, 2 plus 2 plus 1 into minus 1 into 1. One, correct? No, yeah. So this is equal to 0, 1 into minus 1. So the new weights. Now, similarly, do it for the fourth inputs. X1 is minus 1, X2 is minus 1. Now I'll give this to you. Okay, you all of you just calculate and tell me. First you tell me Y in, then you tell me Y, then check for T is equal to Y and tell me. Okay, I'll give you 2 minutes time. All of you can try and give me the answers. Is it done? Anybody?
Ma'am, in this case, do the weights remain the same?
Okay. Let us see. What is Y in you have got, Anupama?
-3, ma'am.
-3. Very good. This is right. So the Y will be a function of Y in, which is less than, like the conditions are there, no? So this is equal to, you got the output Y is equal to -1. Is it right?
Yes, ma'am.
Okay. So check for T, whether T is equal to Y. So here it is satisfied. Okay. T is equal to Y. Okay. This is very, very important. So since T is equal to Y, so you have to retain the same, whatever the weights you have calculated, you have to retain it. This is very, very important thing. Okay. uh, First, so what we have done so far here is, we have calculated the weight for one iteration or one epoch. Okay, so only one epoch is over now. Only one epoch is over. We are done with one. Last case, we have got the weights T is equal to Y. I'll just write it in a tabular form. So X1, X2, target, Y in, Y. You can write W1, W2, B. Then you can write W1, W2, B. Okay. This you can write a table in this way. So here 1, 1, 1. 1, 1, 1 minus 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, target 1, -1, -1, -1. So here 0, 0. I think 1, 1. You can just check 2, 1. Last case y in you have got -3 and y you have got -1, right? And here w1, w2, b I'll write 1, 1, 1, 0, 2, 0, 1, 1, -1, 1, 1, -1. So this is considered to be first epoch. Okay, so epoch 1. Now epoch epoch 2. You can repeat it. Okay, and here you can write w1, the change in weights. So here it is from 0, 0, 0 to 1, 1, 1. So this is 1, 1, 1. So the 1 has become 0. This is -1. Now 1 has become 2. This is +1. 1 has become 0. This is -1. Like this you can write. So this is 1, 2 to 1, -1, 0 to -1. This is -1. So here there is no change. Okay, so actually when there is no change, you have to according to the flow chart, you have to repeat the you have to retain the same weights. Okay, as I have told, this is I have done it only for one epoch or one iteration. This has to be repeated for second epoch. Okay, you can do it for the second epoch by yourself. You can please continue. Okay, for second epoch, even after for second epoch, like finally you will get w1 is equal to w2. Sorry, w1 is equal to 1, w2 is equal to 1, and b is equal to -1. Okay, let me just go back to the flow chart. So here, just check for whether y is equal to t. If no, you retain the same weights. Okay, then if weights if don't change, then you can stop. If weight changes, this will be continued. So like this you can do it for one or first or two iterations. If you are getting the same weights, you can stop here, considering this to be the termination of this. And or else if after
I'm
second epoch,
answering, by the way.
yeah, yes, any doubts?
No, ma'am, sorry.
Okay, okay. Now say here even after second iteration, okay, the it will be w1 is equal to 1, w2 is equal to 1, and b is equal to -1 will be mm, retained, or it will be same. So and at this point of time you can stop this. Okay. Now another thing is you can draw I have told you how to draw a linear separable line, right? You can draw a linear separable line. How to draw it we have already discussed. And check whether the line separates the positive response and negative response. So whether it separates positive response with the negative response. Okay, you can draw it and see. Sometimes it so happens that when theta is equal to not 0, so you may have to draw two separate lines. Okay, one to separate from positive response and 0, the other one is 0 and negative response. Okay, that is in your second this one part. But now what I want you to do is similar to this AND gate, you can just try for OR gate, NAND gate, NOR gate, or any other gate. At least one or two iterations, one or two epochs you have to practice. So then only you will get a confidence like how perceptron neural network model can be used to implement this type of functions. Okay, this is one problem only I have discussed now. Now I will do one more problem so that this will be clear. Is this anybody any doubts? Is it clear? Hmm?
Yes, ma'am.
Okay. We'll solve one more problem. Okay. I'll just write the problem. That the two patterns A and B are represented as shown in the table. Classify these patterns using Perceptron network. Assume initial weights to be 0, theta is equal to 0, and alpha is equal to 1. A, B, x1, x2, x3, x4, x5, x6, x7, x8, x9. B, target 1, 1, 1, 1, minus 1, 1, minus 1, 1, 1, 1, 1, 1. So here 1, 1, 1, 1, 1, 1. X8 is minus 1, x9 is minus 1. This is 1, this is 1, this is minus 1. So this is the table. Okay, so two patterns, pattern A and pattern B. It is represented in this way. Okay, this is the target, this is the bias. Now what you have to do is you have to design a neural network model using this perceptron network model. Okay, initial weights given 0, theta is 0, alpha is 1. If it is given, you don't have to worry. If it is not given, you have to assume. How to assume that I will tell you later. Okay. So here activation function y is 1 if okay, y in is greater than 0, it is 0, just like previous problem. Output I mean y is 0 if y in is 0, and it is minus 1 if y in is less than minus 0. Okay, so let us start. So initial, first I will consider the first set of input. X is equal to I'll write here 1 1 1 minus 1, 1 minus 1, 1 1 1. Hope I am right. 1 1 1 minus 1 1 minus 1 1 1 1. Okay, and now target is 1. Okay, let me calculate the net input y in. Y in is equal to, you know that, beta b plus x1 w1 b plus x1 w1, or it is b plus sigma I is equal to 1 to n xi wi, right? So you just do, because since the weights are 0, it is obvious that this is 0. If this is 0, so we have the activation function. We have the activation function y is equal to, compared to 1 0 minus 1, if y in is equal to greater than 0, it is if y in is equal to 0, and if y in is less than 0. So now here what is the value? Y is equal to, for this case y is equal to 0, right? Y is 0, so target is 1, right? So check whether t is equal to y. So t is not equal to y. So now compute new weights. Compute new weights. So the formula is W1 new is equal to W1 old plus alpha T into X1. Okay. So you calculate W1 new. Similarly, W2 like this. You calculate W3, W4, W5. Like this you calculate up to W9. Okay. W6, W7, W8. See any change in the weight. Okay. So any change in the weight you just check. And B also, B new also. You can write it in a table if you want. So I think you will get W1 1 1 1 minus 1 1 minus 1 1 1 1 1. So there is a change in the weights because we first what we do is we assume with zeros. So now all have become 1. Now what you need to do is you consider the second input x is equal to all that 1 1 1 1 1 1 minus 1 minus 1. Calculate y in, then calculate the output, check whether it is equal to target. If it is equal, then you can retain. If it is not equal, then calculate the new weights. This much work I'm giving it to you. You can take 5 minutes and you can give me the answers of new weights. Is it done? What are the, can you just tell any one of you for the second input, what is y in, what is y, check y is equal to t, then if it is not same, what are the new weights? Anybody?
Ma'am, yn is equal to 2.
Okay. Y is?
Y is 1.
Okay. Is it same? No, it is not same, right? So now you need to calculate the weights, all W1, W2, W2. I'll write here the weights. I'll just draw the diagram. That time one of you can tell the weights. Okay. So it will be something like this. Just draw it. So x1 to x9, x1, 2, 3, 4, 5, 6, 7, 8, 9. This is my y. This is y. This is y. x1, x2, x3, x4, x5, x6. Huh. Uh, say one thing I want to tell here, since it is not equal, you would have got the new weights, w1 new till w9 new in and bias. Okay, and please note that it is just a completion of one iteration or one epoch. You can proceed, okay, till you can train this network further, so that it will converge. You will get even second epoch when you try, if you get the same weights, okay, so that time you can stop. Now I am just stopping here after one iteration only. It will be, if exam point of view, if I tell, it will be mentioned in the question how many epochs you need to do it, okay, when you have to stop training the network. Okay, so here this is, if I draw w2, so it will be, this is 1b, this is w1, w2, w3, w4, w5, W6, W7, W8 and W9 after one epoch. Okay, after one iteration. Now can you tell me the values? W1,
0, ma'am.
okay, W2,
0.
W3,
0.
W4,
-2.
very good, W5,
0.
W6,
-2.
W7,
0.
W8,
2.
okay, W9,
2.
B is
0, ma'am.
okay. So please note that this is the perceptron network for the given problem. Okay, and we have done only one epoch. If it is asked, you can for the second set of for the same inputs, you can try second time. Okay, for second epoch. But see, it is always when we calculate manually, it takes time, right? A lot of calculations. So if you use some programming language or if you use MATLAB, this will be very easy. Within no time, you get the answer. Okay. But the logic is this. How it works, you must know. The theory behind the all these neural networks, you must know. Then only you can make use of MATLAB or any other toolbox, so that you will get the you can train the model for the particular application. Okay, so I'll give you one or two problems homework. You can just try. As I have told, first few questions, it is it's implement, okay, implement or okay, then we have done and or okay, at least one you do, or using perceptron network, neural network model. The other part of the question remains same. Okay, you can just try. Second question I'll give you. This is one. Next, find the weights required to perform the following classification using perceptron neural network model. Okay, so I will, the inputs are x1, x2, x3, x4. These are the inputs. This is bias. Then this is target. Okay, so when all the inputs are 1, of course bias is 1 only, it is always 1 bias input. So output is, target is 1. When you have -1, 1, -1, -1, this is 1. When you have 1, 1, 1, -1, you have -1. And when you have 1, -1, -1, 1, you have -1. 1, 1, -1, -1. Okay, 1, -1, -1, 1. Correct. 1, -1, 1, -1, 1, 1, 1, -1, 1, -1, 1, 1. Okay, so here W1 is equal to W2 is equal to W3 is equal to W4 is equal to B is equal to 0. Initially, you can assume it to be 0, and learning rate you can assume it is 1. And what I suggest here is you can take theta is equal to 0.2. Okay, theta is equal to, you can take 0.2, and let us see how you get the weights. What you can at least try for -2 to 0 to try for 2 epochs. Okay, please do it for 2 epochs. Okay, any doubts, anybody? Is it
No,
clear?
ma'am.
Is this approach fine?
Yes, ma'am.
Good. Next is Adeline. Okay, that Adeline I will discuss in my next class. Okay, again similar to this, what I will do is Adeline network, how it is how it can be implemented, I'll explain first with the help of flow chart. Simply if I tell the flow chart, it may not be like, you will not understand it. Then I'll take 2 problems and I will give you the clear understanding of Adeline networks. Later I'll also tell you the another one, that Okay, so I am back. Maybe because of the poor network connection, I think I could not, I mean, I lost the contact. Okay, I was just telling about Adeline and Madeline. After that, a very, very important topic we are going to discuss, that is, I probably next week. So this next class I will do Adeline. Next week it is back propagation network. That is the one which is commonly used for all the applications. That is back propagation network. We will solve some 2 to 3 problems, and I'll take some 1 or 2 real time examples also, how back propagation networks can be used. These things I will discuss. Okay, that is next week, most probably. I think that's all. What I want is, see, if it is a like a physical classroom teaching, I would have asked you to solve these problems in the class and get the answers verified. Since it is online class, it is meaningless asking you to solve these problems now, right? So what I suggest is, we have next half an hour. You please, all of you, please solve these problems, whatever I have given. Okay, and next class beginning, we will discuss the solution. Before that, I'll take attendance. 1 second. Okay, that's all for today. If you have any doubts, you can ask, or else you may leave. Thank you.
Thank you, ma'am.
Yeah.
Thank you, ma'am.